and take a look. Yeah,
That's okay.
yeah.
Well, you can get them after, so they can be good practice for later on. Although you'll see the solution already, but that's okay. I think I'll start in another minute. Okay, I'll get started. So this is the last of like a series of 3 talks. Each was supposed to give a kind of overview and advice and things for aspects of a kind of standard data science interview process. This last one is going to focus on data science challenges. So these are pretty common. Didn't see them in every interview process that I've been through, but roughly half, where they give a document with some data and with a few questions essentially, and give about a week, 3 to 5 days, work days, for the interviewee to complete it, submit, and it becomes a major part of whether or not you got an offer. So it's pretty daunting and everything. I was fortunate enough to get some offers after doing these, and so I've kind of compiled 2 real challenges that I took and completed, and got offers after these. So these are good examples of, like, ideally what an example solution to a data science challenge would look like. So we're going to start with Pepsi's. So this was from an interview process from Pepsi. And I'm going to just go through their prompt and then go through my solution. And feel free to stop me if you have any questions. So they gave us a, excellent. They gave us, I'll quickly, hey, Tigran. So just quick intro of what we're doing. This talk is going to go over data science challenges. So it's a pretty standard thing that you might experience during data science reviews. Well, they'll give you a data science challenge, some data, some questions or everything, and if they expect you to do analysis and give it back to them, and then that'll be a major input into whether or not they give you an offer. So I've found 2 real-world data science challenges that I completed and got offers from. So we're going to go through the challenges and solutions, and they'll give a good example of what an answer to a data science challenge might look like. Okay, so right now going through just the prompts. So this is from Pepsi from a year and a half ago or so. They gave a simulated set of time series data with some example products what they might have, whether or not that product was promoted, the price of that data, and then the amount of total sales of that on a given day. Some notes about what's going on. So the point of the analysis to predict dollar sales in 2019. So all of the rows for 2019 on have that column blank. A little note on what the promoted binary variable means, is whether or not it's promoted or not, and they don't want us to go into looking into the relationship between 2 of the variables they give. And they say that you should expect this product ID and date pairs to be unique. Then they tell us what to do with the analysis. Start by cleaning, computing, and I'm looking for anomalies and duplicates, etc. And yeah, just sort of like on your own, what would you do if you'd given a data set without any prior knowledge of what to do with it? Then they tell us, so the next part is part of feature engineering, but they tell us there's one feature specifically they think is very important that they want us to engineer. So it's a feature that doesn't exist, but that we should be able to calculate and create and use it in our final model. And that's maximum retail price, which they go on to define. This is an example one product's price over time. And the MRP is this orange line. So essentially the maximum price that that product has been sold for in the past. And then they say there's these like random spikes they say are anomalies and should ignore them, but it's, you know, adds to the challenge of doing that calculation. Yeah. Then the final submission and what they expect, Jupyter Notebook, great, a Python notebook, and a model that predicts the final sales. And they want to actually, they ask for that CSV file. So presumably they take your analysis, look at the notebook, and then also do some sort of check to see how accurate your findings really were. Clear? Great. Okay. So this is what I submitted. So I'll go through it and make some quick points. I think Jupyter Notebooks let you do Markdown. For any of these, I like to put real English and text into the notebook to make it kind of a report. So the notebook both, you know, does the analysis, does the models, whatever, but it also has text saying what I was thinking, how I did everything, and kind of makes a final report. So I set it up this way. So in the very beginning, I say what I'm doing, what the notebook is about, what I did, and the final results. And so, you know, immediately they can look at it and say, okay, this is what this person did and what to expect on the rest of the notebook. Then I followed the steps pretty much as they laid out. First, looking at the initial data exploration. So, you know, loaded in the, and I'll say, you know, obviously this looks like a nice linear thing. When I'm working on these notebooks, it's not. You know, probably like 3 or 4 different notebooks that I was creating. And then when I finally want to submit my answer and results, I formalize it into one nice linear report. But, you know, when I'm doing work initially, it's not going to look this clean, obviously, when going through it. So I, import these packages, taking the data. So that's just the data that they included with their data challenge. They say that I shouldn't expect duplicates, so I drop duplicates. And then just checking what they said, if there's any duplicate pairs. This notebook won't work right now because the way it works, so I'm not going to be able to run it, but it should have most of the outputs already there. Then I do a few things that, again, you know, I think when I was doing this analysis, I found that it was useful to do these transformations, but I didn't know immediately that this is what I wanted to do. But I find often it's useful, instead of using like a date string like this, to spit that out as separate values, and that can be useful. So I do this immediately and just pull out the month, the year, and the day out of the date string as their own features. And then I also add a volume feature, which we'll see later on becomes very important. But I think just even before looking at the data, I added that as something useful to do. And then just look at the data. So this is what the actual data set looks like. You have a product ID, which is some generic product, a date, whether or not it's promoted, the price that it was sold for at that date, total sales in dollars. And then these features that I added, month, year, day, and volume, which is just simply sales over price. And then start doing some EDA. So I think to start, I just simply plotted some of the relationships between variables. So looking at the relationship between price and sales of just all the products, just one big scatter plot. And you can see there's some relationships. This is nice. So as price goes up, you make more money, dollar sales. Similar, looking at price and volume, the more the product is priced for, the less you sell. That also makes sense intuitively. And this is sort of like a fanned outline for all the products. Some other plots, whether or not, since promoted is categorical, just binary, 0 or 1, used a box plot to show the relationship between promoted and, this is volume. I think I didn't put that on the y-axis, but that's okay. And show that when things are promoted, it seems to shift the distribution up a bit, so we get more sales. Some other things, so like monthly, we can just see that overall there seems to be some differences between months. on total sales. And if you just look at like weekdays generally, there doesn't seem to be much of a relationship. So that's, and then I try to summarize that. Probably summarize the text somewhere. Anyway, just trying to make it clear, like this is my thought process. This is how I did EA, and this is what I went through. Okay. So obviously this was looking at just all the products as one entity, like ignoring the fact that they're different products and they might have different relationships with all the features. So the next thing I did was just plotted the relationship, but filtering down to different products. There are like 100 products, so I didn't want to plot all of them for this, just for this notebook, but I just randomly chose 9 because it makes a nice, 9 3x3 plot, and plotted 9 of the products. So this is the relationship between price and dollar sales. And I also separated out just by color, which month it was. And also the look of the plot will be years. And you can get a lot of information from just this plot. So products seem to have these like nice parabolic relationships between price and total sales. There seems to be differences between months. So different months lie on different plots. So it seems like, month is like moving a more general function up and down. But it's nice. We're starting to get some like clear relationships between what's going on. Next, plotting just price and volume. This ended up looking really nice. And obviously they made up this data set. I don't think like in the real world, you can expect things to look quite so clean. But it's able to we can eke out the relationship nicely. So when you raise the price, seems to just sell less on a perfect linear line, and the line changes slope and intercept based on month, more or less. It seems to be what's going on. A lot of them seem to have the same slope. Some of them are slightly different, but yeah. Then I did a few more things, also just showing, the relationship between month and volume for different plots, and showing again there seems to be some seasonality. It also seems to be different for different products. Some products don't change month. Some change a lot. Yeah. And finally, I just did the day and said here that there wasn't much of a relationship, because you see it's pretty much constant across. Summarizing these things, so now it's clear. Okay, this is the EDA that I did, and then it'll be clear what I'm doing next. For feature engineering, yeah, since they asked for calculating MRP, maximum retail price, that's obviously what I will start to do. I also added a few of my own features just for fun to try to make the model better. Yeah, let me talk more about that when we get there. So the maximum retail price, I had to redefine it and plot it again just to be able to talk about it more clearly. And then I start to create the algorithm. So first, I don't know if I smoothed it out yet. But yeah, so this function is just a helper function that will go back in time and see what is the maximum price before this time. And I use this in this, and then this is my first iteration of the MRP algorithm. So it goes through the test data and does a rolling window back in time, and calculates the mode of that rolling window. And then it looks like I also backfill gaps in it. And so this was all obviously done in a separate notebook when I was like formulating this engineering, but I didn't include all of like the background work in the final analysis, just like what the final algorithm was and how it worked. I also, smoothed the price out, and then, so it looks like I kind of like go through this calculation multiple times. First doing this rolling mode, then filling in NAs, smoothing it out by taking out any outliers. So anything that's above like the MRP that I calculated before, so like this rolling average, I set to the rolling average. And then once it's smooth and nice, we could just use the max up to column, which is like the intuitive like definition of what MRP is. Okay. So I say, it works pretty well. I acknowledge that it's not perfect. And, where it's not perfect, I think specifically, like in the very beginning, sometimes when there hasn't been a lot of data yet, and maybe there was a weird, like a drop early on, it won't capture that. So the MRP looks like it's really low. And this product shows that, for example, and here. But I just say, don't have the time to figure that out yet. And that's price. I call price shock. I made it up. And essentially, it's when a price increases. So like right after the MRP increases, I seem to notice there might be a decrease in sales that kind of goes away over time. And so I show an example of that, and then make up a calculation for what that is. And I don't know if I see. Yeah, it's a rolling standard deviation of the MRP. So when there's a change in the MRP, it'll increase, but then over time, that standard deviation will go down to nothing when the window is passed. Clear? Okay. So did some feature engineering. Next, I went through and did the imputations. So first, just plotting out all of the columns and how many values there are. I think if there are no nulls, you'll have this how many total rows there are. And then you can see dollar sales, there's a lot, but that's because the 2019 data, we don't have any data. But then other things like promoted, there's some nulls, price, there's some nulls. Yeah, really that's it. And this is on the raw data, not the engineered features from before. So just saying this, going through my prod process, so it's clear what I'm doing. If you look at, so I said, I think that dollar sales are only null when in 2019, this just confirms it. So if I look at data only for 2019, dollar sales is the same as product ID and date. Then just a quick thing to say whether or not the missing values are random or not. And so I just plotted, I think this is in time where the values are showing. So the y-axis is kind of time, and the x-axis is different columns. And you can see dollar sales obviously just only shows up to 19. We knew that. The date's never missing. But then just like this is a really simple analysis, just like it looks like the price and promoted don't have a real pattern and aren't related. And with that, I said, okay, I'm going to fill them in. I was kind of assuming there is no real pattern. Then I just wanted to quantify, like, okay, how many missing values do we actually have? And so for different products, I believe, I said what's the percentage of missing values for those products? I believe is what I'm doing here. Yeah. And some products have as much as 7% missing value. So it seems like, yes, and we need to deal with this. It's not something we can just throw away numbers. Talk about my strategy. So since this is time series data, I said I'm going to impute values based off of the most previous non-missing value. So if there's some week and I'm missing data on the price, I'll just use last week's price if there is, and if that's missing too, then I'll just keep going back until we don't miss it. And that's what I'm going to do. Then I summarize the final approach. So how to calculate my MRP, adding in the price, filling in values, etc. Then I go through the modeling approach. So I decided, I think based off of like the early EDA, that I want to do a different model for each product. And they actually mentioned in their thing, like, I think just to do a linear regression. So I was going to do, I did a linear regression. Yes, we strongly recommend simple linear regression. So I did that. So, but I knew from previous EDA that the relationship is much stronger when you separate out product to product. So I do that. It is a time series. I just wanted to make a note here that I am splitting the train test split for everything before 2018 or 2019 randomly, which can be problematic if you're working with time series data. But I'm not using previous data as a feature in the row. Each row is kind of its own standalone thing. And so I say it's like sort of okay. That's sort of like just a note. Like I understand this is time series data and there's some things to worry about when you're working with that sort of data, but because I'm doing this sort of simple analysis, I'm not going to worry about it. And then I did this analysis where I, trained each model for each product with a different set of features. And I do that just to then be able to answer some of these questions, like, are these new things that I'm making, like, is MRP useful? Does the shock really matter? And stuff like that. So I'm just training the model multiple times, looking at the outcome and how much improves the accuracy of the model. So this is just splitting up all the data into like a dictionary of different data frames. So the dictionary is going to have a product ID and then that product's data with all of the engineered features and things in place. That's all I'm doing there. And then I wrapped the like total modeling thing in some sort of code so that I could do this analysis, but with different sets of features. So this model training is done as a function of the features that you want to use and on different targets. So if you want to look at targeting sales or volume, essentially, is what I want to do. So we go through, do this nested for loop where I'm training the model for every different set of features that I'm interested in and the different target variables I'm interested in, and just printing out the scores training test, and then kind of simply can go through and say which model, worked best for which features. In short, the best models were predicting volume and using some combination of discount, MRP, and price. I think I say clearly you don't need all of them, and it makes sense intuitively because the discount is just the difference between price and MRP. It's a linear model, they're collinear. So you don't need all three. And then promoted, and I think I say shock is also useful as well. Okay. So again, I go through in plain English, like what my thought process was and what I want to do with the model. Volume, clearly easier to predict than dollar sales. That makes sense. And based on the EDA we did earlier on, that makes intuitive sense. And then I say, clearly discount price and MRP are multicollinear. You don't need all three, but having, I think, at least just discount, because discount is a linear combination of the other two, works. Promotion and shock. Yes, and I said that I think that they both improve the model, so I'm going to include them. So after this feature selection process, I did one last thing, make the final model, and look at the results. So yeah, I discount MRP, shock, and promoted, and I'm predicting volume. And then for the final data set that they need, they ask for dollar sales. So we'll just simply, after doing the prediction, multiply volume by the price and get the dollar sales. So I get the final model, using my wrapper from before, and then take a look at the residuals, since this is like, if you're doing a linear regression, like it's a good idea to do this. So like what kind of model validation steps you'd want to do for whatever model you're trying to use. Plotting the train test score, they look pretty good, pretty close, and higher than other models I was working on. The residuals look like a nice normal distribution. So I say that I'm pretty confident in my model. I'm gonna create my final data set. So the final data set I do here, I assign and use the model to make the prediction. And then I look at the results for some products. So again, so there's 100 products. I don't want to look at everything, but just want to see how is it working and look at the prediction. It doesn't look good. So I'm plotting the total sales that they give us, the predicted sales that we're giving, and then some of the features that go into that. And just qualitatively showing, okay, this makes sense, and looks like my model is doing a good job visually. Okay. And in the end, saving my data set that they asked to give, and going through some conclusion of like, what is the final thoughts on the analysis, and if I had more time, what would I do? So in this case, I say that I think I built a pretty good model using the features that we engineered. Yeah. And then some next steps and just thoughts that I had while going through this. And if I had more time, it was like what I would do if I had more time. So one was improving seasonality. Right now, the seasonality is just every month is a different feature. And so for different months, you'd just add a different amount to the thing. And so if you look at some of these prediction curves versus the dollar sales, they have these kind of blocky results. And that's because every month you're adding a different value, essentially, is what we're doing. And so I'd say, obviously that might not be exactly how it works in the real world. And so we can improve that analysis. MRBP calculation, I just reiterated that I know it's not perfect. And there were some things I could improve, especially errors in the beginning. In the residuals, we do see some just like large spikes. And so I said, if I wanted to like, what I would do next to improve model would probably investigate what's going on in those spikes. Then I talk about interaction terms. The slopes seem to vary month to month and potentially over different variables. And so I could add in different interaction terms that try to take into account the interaction between multiple features. Lastly, I did a different model solely separate for every product. It's possible that changing the price on one product changes the sales of another product. So I mentioned like that's something that we could do to improve the model, is including other product data in a single products model. And lastly, I did a simple linear regression. They suggested doing a simple linear regression. I think like that's probably what you should do in this data challenge. But if it is time series data, there are lots of time series models you can use to make a better model. And then I say thanks and hope they enjoyed reading and giving off. Okay. More or less clear. Any questions? Otherwise, I'll go on to the next challenge.
Hey, thank you, Michael. Sorry, I kind of joined in like 2 minutes late.
No worries.
I was just curious, did you decide doing time series or just it was appropriate based on the data?
Say that again. So the data is a time series. So if we look at like just the original structure of the data, it is a time series because it's a product with a date and then things over time. For the model, I treated it just as a simple linear model. I think the step where you often take when you start doing models as a time series is when you're using previous data to predict future data. And so that format, we'd have like previous weeks or months or whatever sales as a feature in the row of the data. And I didn't do that. And I said, that's obviously something we could do. But since they sort of asked for simple linear regression, I shied away from it. Although it would still be a simple linear regression, sort of, time series definition. But yeah.
Gotcha. And just so you don't, I think there was a section where you mentioned, since, like you said, there's like when you're doing the splitting part, you said that you don't want to kind of use different years, or meaning you don't want to include the seasonality in your train and test split in a way, I think.
Something like that, yeah.
Yeah. So I just kind of wanted to see how you.
In this case, I just did a simple train test split. I think when you're working with time series data, you want to spend some time thinking about how you do your train test splits, so that you're not having data leakage from future data getting into your model. I don't have more to say about that right now, but I think just like if you were doing something like that, just spend a little time and do a little research on the side, so to decide how you're going to do your training test. But
And
yeah.
Yeah, go ahead.
Oh yeah, I believe actually the boot camp, I believe, still has some like time series quick documentation and resources to help. Yeah. So I just like, I'm not going to do that and just say a note that I know that there's probably something more you have to do. Yeah.
Gotcha. And then for the missing values, you said, so you chose the most recent.
Yeah.
Okay. Okay.
Which I think is fair, because like every time we have a new data point, if it is missing, you will have previous data. Like I wouldn't want to look forward in time to do the imputation, because I think that would be cheating in some sense, like you're getting future data into your data. But I think that backfilling is okay.
Gotcha. All right. Thank you so much.
Yeah, of course.
Hi, Michael. I was wondering if they provide you with any feedback.
Yeah, not really, other than like you're good to go to the next step. So I didn't get any. I don't believe, and this was a while ago. This was like a little over a few months ago. I don't remember the interviewers asking me much actually about this challenge in this case. It was sort of like just a check mark, like this, this guy completes some technical challenges and now he's okay to go on to the next stage of the interview. I did get an offer, so I know they at least liked it somewhat. Yeah.
Thank you.
Yeah. Okay. I'll move on to the next data science challenge. Okay, so I didn't get it. Sorry, just trying to. Okay. Everyone see the Word doc? Do you guys see this Word document?
Yeah.
Just want to make sure I'm sharing my screen. Okay, great. Okay. So this was Anheuser-Busch's data challenge. Again, that's where I currently work. We got an offer there. So we'll go through their challenge and the solutions I give them. So they're giving us this prompt. Essentially, they lose 4 to 5% of their sales each year, they predict, because of out of stocks. And they want us to create a strategy. So they don't even say like a model or anything, just say design an approach to minimize out of stock and maximize on-shelf availability for our products. They give us some data sets and explain what they are. Basically, a data set that's saying whether or not a product was out of stock. Sales weekly for the stores they have across the US, and then just a data dictionary describing those. Okay, they do want us to predict. So they say, yeah, in the end, make a model or do something to predict whether or not something's being out of stock for a product at a store every week. And then make a recommendation on like how we should use this knowledge to maximize shelf availability. Clear and easy to read code, build methodology to maximize on-shelf availability. And yeah, then they just note also that you can do this on a sample of stores. This will become clear when we get into the data why they say that. Essentially, it's a pretty sparse data set. And yeah, so this is a simplification. And that we can do, yeah, they just say you could do this for sample stores, not all the stores. And then the specifics, 5 days, etc. Okay, so we'll go to any questions on the prompt? Otherwise, we'll just get into the solution, or my solution, which I think is a decent solution. Cool. Okay. So again, this is right now looking at just the HTML I sent them. I don't know if I sent them also the Python notebook, but yeah, any Jupyter notebook you can output as an HTML. It formats nicely immediately into this nice way. So I often do that when I'm communicating my like EDAs and work. So I start off the same way as I did before, kind of like what is the purpose of this notebook, and then I summarize the whole analysis in the beginning. I think, yeah, to make it clear to anyone reading it, like what did I do, what was the outcome, and what's going to happen in the rest of the notebook. So in this, I just use the logistic regression, which makes sense because out of stock is kind of binary, whether it was out of stock or it wasn't. And that'll give you a probability of, given this data point, next week will I have out of stock. That's sort of the model. And it didn't, in my opinion, actually, I didn't know if it worked very well, but I think this was like good enough for them. I'll say this is real data. Pepsi gave fake data, and that fake data set, you were able to make a pretty good model. This was a lot harder. And when I was doing this, I remember like banging my head against the wall. So I was worried I wasn't good enough, but did my best and it ended up being good enough. So don't wait, if you're doing something like this and it is real data, don't get too worked up if it's not giving, incredibly good accuracy or something like that. So in this case, it's only predicting correctly 30% of the time whether or not something was out of stock. And of that, it's misclassifying, it's missing about 5%. So it's saying 5% false negatives or positives, depending on how you want to say that. So 5% of the time, it's saying that there are things in the out of stock when they weren't. Otherwise, it's getting 30% of the total out of stock. And then I say, just including, because they asked for kind of like I don't know if they call it a plan of action, but they want to include like, what are we going to do with this analysis? And I just, some verbiage there to say, obviously we have this model which can predict out of stock. It costs something to stock more. So if you want to send more, it's sort of this optimization problem where it'll cost more to stock more product, but we can use our knowledge of what the cost of stocking more product with the outcome of this model to then sort of make some decisions about whether or not we should stock more at a store. And so just sort of like trying to give some business context and show that I'm thinking about the problem from like business context, et cetera. Cool. Clear, everyone following so far? Okay. So next I just start with the description of the data. So it has their scanned sales data. I just say some quick things. This data set has a lot of extra columns and things. So I'm only looking at a few. For example, they call it product movement. I think it's just volume, like sales, total amount, and dollars are perfectly linear dependent. So I only use retail dollars for the analysis. The product weight, there is like a column saying product pounds, but it was very sparse and doesn't seem to really be used very often. I imagine now that I've worked there, the account could like weigh their thing, but doesn't always. And so they just don't always get that data. And gross margin is related to, but not the same. Yeah, again, similar, also often zero. And so I sort of said, I'm not gonna use it in this analysis because I don't think that's like there often enough. Then I talk about the out of stock data set. The coverage is low, and I just say that in the beginning. There's really only out of stock occurrences. I plot it here, yeah. So like, this is a log scale on the left. There's like much more out of stock occurrences after a certain period of time. So I'm sort of making note of those kind of anomalies in the data sets. I imagine what happened here is that before whatever date this was, 2017 or something, they were only working with some subset of stores, and they started to roll out their like actual tracking of out of stocks to more stores. And that's why you get this big jump. There isn't a lot of overlap between stores and the different data sets. I think they have like out of stock data for just one division. I don't know exactly what that means with some geography. And they have out of stock or sales in overlapping in just one. So for parts of this analysis, I only use the overlapping data. At one point, I try to extend it to the rest of the data set. So I sort of have two models based on the total coverage. We'll go into that later. Okay, some plots. Then I get into the EDA and I show, yeah, that there's only one division where the sales data intersects with the out of stock. So just saying, yeah, that's where I came to that conclusion. First, I look at individual stores product with their out of stock data, just comparing both, sales data with out of stocks and trying to see if there's any relationship or just visually like making sense of what's going on. Again, I'm only looking at 705 division, so I really filtered down the data sets because that's the only place where we have both sales and out of stock data. And I looked at it just at a store level. So this is one store's total sales and total out of stocks. There aren't a lot of out of stocks for a single store. Many had 0, and some only had like, these examples of 1 or 2 showing up. So next I looked at it at a product week level. Yeah. And so aggregating all of the stores in that division that has both sales and data, and then plotting the relationships. This way you can get a more clear relationship between the two. I'm going to do that for a few different products. And my hypothesis after looking at this is that out of stocks seem to happen after an increase in sales volume. So when there's a jump in sales, it looks like there's sort of this delayed effect where there's might be more out of stocks. And that seems to be sort of happening. That's what I say. And so I want to turn that into a feature that I'm going to use for this model. Yeah. An increase in sales volume of product may result in increase of out of stock occurrences. So that feature I'm going to use for this is the previous week's average change over some period of time. So how much are the sales changing over this month, from month to month? So this feature I call like product weeks store like growth, sales growth. This is plotting the total out of stocks on the y-axis and then the sales. And so there's very little out of stocks on the negative side. So basically, when there's positive sales growth, you're more likely to have out of stocks. That's what this plot is trying to show. Then I do a few more things in similar vein to try to show there might be some other relationships. This is just at the change at a product week store level. I also included the aggregated. So maybe that if a store has a lot more sales, this is like just a week store level. And also product week. So yeah, a store might be getting, my theory was a store might be just be getting a lot of sales and so they can't keep up with demand, or a product is being bought out from all stores. And so there's some relationship. The product seems to have a better relationship than just store, which seems to make sense. So there's like higher demand for specific products at certain times that the total distribution can't keep up with. And so we get out of stocks. The last thing I did was I saw, especially in these sort of charts, often one out of stock might lead to other out of stocks. So there's like it happening in more than weeks. So another feature was just simply whether or not binary there was out of stock last week. Or maybe it was total out of stock last week, but either way. So I'm saying if there's out of stock this week, there's some likelihood that it might be out of stock next week. And this is plotting that relationship. It's not incredibly strong, but yeah, a little hard to see the relationship. So next, I built a model using those features. The part of the model is just simple regression. Since it's for using time-sensitive data, the taint split is performed by splitting available weeks into 2 sets. Split it 4/5 of the total covered weeks. So I think what I did was the training set was the first 4/5 of the data that I had, and the test set was the previous fifth. So basically on a model trained on some previous set of data, how well will that test data model do in the future? I also mentioned that the data set's imbalanced. There's very few out of stocks overall. So I use different weights while training. Yeah, there's more weight given to out of stock rows. The out of stock data, I turned into a Boolean value. So I think there was some feature engineering just to be able to turn the out of stock data set into this total out of stocks. My model is just predicting whether or not and it is out of stock or not, so it's just binary. And I did two things. First, I did one model that's using just the overlapping data, which makes sense. So it's only predicting on the stores where I have both sales and out of stock data. Then I tried to do a model that uses this on all of the stores. Or that's not true. It's a huge data set, so I still filtered it down. But yeah, it's using less features essentially because not all the features are available for all stores. Okay, so we get into it. Merging all the data sets, creating the out of stock binary version of total out of stock, pulling in the list regression, defining the final features I want to use. So I decided product week sales growth, so whether or not a product's been growing over the last, or how much the change in sales there was in a product over the last week. And then out of stocks the previous week, and then I think I just did out of stock like 2 weeks ago as well. So whether or not it was out of stock last week and the previous. And the target variable is this week's out of stock, obviously. This is where I do the class weights, I believe. So this is just built into sklearn to let us do that. I think that, I don't remember exactly what I was doing here. But there might have been I might have divided by 0 or something. So it was like infinity showing up. I just dropped those. So there's doing some cleaning as well. And then I do the train test split based off of time. So instead of doing just like, a sklearn train test split, I divide it into 4/5. Train is the beginning, and test is the end. Yeah, and then I fit the model. Obviously, the accuracy looks pretty good, but that's just because there's not a lot of out of stock stores. And so what we really want is some other metric, something like ROC, AUC score, and then also the confusion matrix. So I think it's important when you're doing sort of a categorical model, you're not looking at just plain accuracy, because depending on the problem you're solving, it might not be that useful. In this case, we could just say that it's never out of stock and get a pretty good accuracy. But what's really important is this number here, is how often are you getting the out of stocks predicted correctly. And then I create the final prediction data set and just take a look to see if it makes sense. So the probability of out of stock is on the right. Okay, that was the first model. Second model was using the larger data sets. And there's some more feature engineering. I think it's similar, just slightly different because of the amount of stores I'm using. Okay, pretty much copy and pasted, just a different feature tree in the beginning. The accuracy on the test set isn't so bad. It's, I think, a little lower if we look at the smaller data set. And then the ROC score similarly is a little lower. So kind of what you expected. It's not so bad. You can see the numbers are a lot larger. There's a lot more out of stock. There's a lot more stores. And so it's pretty good that, even on data set, which a lot of the stores don't have sorry, lost my train of thought. Anyway, it works for the larger data set, even though we don't have all the features at the granular level, at the store granular level. Okay. And then I summarize the analysis. Again, I say, it looks like it's okay. The total accuracy I say is inflated because of the imbalanced classes. So what I really want to look at is confusion matrix and ROC score. But even then, we're getting roughly 30%, 50% we're capturing out of stocks with only some small amount of false positives. And then summarizing again what we could do, using this with a combination of the cost of stocking more, we can optimize our profits. So it's kind of this balancing. We don't want to just always stock if we have a prediction because it'll cost more. Yeah, smaller data set performs slightly better, but the dollar data set seems to work pretty well. And then the next steps of what I would do if I had more time. I think, yeah, having more mapping data would be useful. So also adding in more data for different products and stores. So do we have attributes to not just treat products as a random ID or an ID, but maybe similar products will have more demand at the same time or something like that. So we can start grouping things in and working on things and interacting. Yeah. And I make some other thing. Yeah, I'd say, I did a lot of things, like I imputed, I filtered, and did things without really knowing exactly how this data is being come to be. So I think I could use a better strategy, I say, if I knew where the data was coming from, which is real and a real problem currently still working at the company. Yeah. So that's more or less it. I think this challenge was, in my opinion, a lot harder than the Pepsi one because it's real data. You have to make a lot of decisions about how to treat it. And there isn't a very clear trend you can pull out. I think like by the end of my Pepsi EDA, I had these very nice plots where you can see a linear relationship between price and volume and like month to month. And I was like, okay, like I'm gonna be able to make a good model. I know from these plots that we can make a good model. I was not so confident after the EDA on this, where the best I had is like, okay, like maybe when there's some sales growth, there's a chance of total out of stock, but it's hard to say. Yeah, any questions? I'll send these out to everyone. So you'll have the whole challenge and a solution to work off of so you can practice and work on your own. Yeah, I think some other last bits of advice, when I was doing these, I treated it like a full-time job. I think at the time I wasn't working full-time or I wasn't working at all. So I was able to spend a lot of time on it. It was like the most, important thing. So they gave me a week to do this. I spent, 40 hours, maybe not full 40 hours, but a lot of time. And I think that you should do that too. It's very important. I think it's pretty impactful on whether or not they give you an offer. I know in this case, this was the only real technical challenge I had for this interview process. And my final interview, we did talk through it a bit, and it seemed like pretty important to their final decision, which was this analysis. So I think like definitely spend the time on it. And yeah, if you're giving a notebook, don't just put code in that's hard to read. My code is pretty hard to read on its own. So I try to always say what is the code doing, and then including lots of like plain English of what's going on and what my thought process is, I think is very helpful. Otherwise, it's going to be very hard for me to judge what you actually did, because no one wants to sit there and just read a long notebook of just code. Even if the final prediction is good, it's hard to understand the thought process. Okay. Yeah.
I have a quick question. So in this case, when you said you don't have good data, so the prediction isn't as good as you want it to be.
Yeah.
In the review process, once you provided the solution, did they go over, this is kind of what's expected? This is the usual outcome of this project where.
Yeah.
Yeah.
They didn't. They just said that this was good. So I guess, yeah, this is probably, I don't know exactly what their thinking was, but my guess is some numbers of this range were sufficient for them. But no, they didn't explicitly say, but they just said, yeah, that they were happy with the results. Yeah.
Gotcha. Thank you. And then just a general question. I don't want to take too much time away, but so you've been, so you've been throughout the whole interview process where, for different companies and all. How do you decide, if, let's say you get an offer, but it's not something you really like, how do you decide to just move on and go to, just continue the process, even though it's, it's a grind?
Yeah. Yeah, I mean, I can only speak to my specific circumstances. I had, when I first graduated the bootcamp, after, several months of applying, I landed 2 offers about the same time. And they were both ones I was happy with. So I was in that case, I didn't have to make this. It was just deciding between the 2 rather than like do I take none and keep going? So I think like be honest with yourself, like, what do you really want? Is there like a number? And if there's like a dollar value that you expect, you should tell them that and see if they'll match it. And they might. And yeah, I mean, it's hard to like concretely define what you want out of a job, but try to think about that, because it'll affect what you want to do later on. And then also, negotiate. Definitely. I think Vivian helped me and will probably help you. You can go back to the boot camp, say, this is the offer that I have. Like, what should I do? Can I ask for more? And they'll give you honest advice there.
Gotcha. Thank you again.
Yeah, of course.
Michael, are you going to share the notebook and the data set soon?
Yes, definitely. So we'll do they should have already gotten the challenges, but I'll send it again just as one zip. So you'll have the Word docs with like the things, the data, and the solutions all in one. So a nice package for people to practice.
Sounds great.
Yeah.
Michael, when you're done with the session, can you give me 5 more minutes? I have something to catch up with you.
Sure.
Okay.
So any last questions? Otherwise, we can probably end the session.
So everyone joining today's session, we can have another discussion session to look into more details how Michael's solution address all the questions, because I know Michael have gone through everything pretty quickly. So if you can spend a weekend to read this in great details, we can have another discussion session next week. So you really digest all the great things and all the smart point Michael generated from these 2 code challenges. It's gonna be widely applied to a lot of code challenges. So yeah, feel free to Slack me. We're gonna find a day after work hour to go over those more in details.
Sounds good.
Thank you so much, Michael, for your generous sharing with us.
Yeah, and I hope everyone finds it useful. And good luck on your interview process.
Thank you, Michael. Have a good one, guys.
Thank you, Michael.
Bye.
Michael, please stay. I'm gonna stop the recording.
Sounds good.
I think Michael